Yo, yo, what's up, what's up? Welcome back. Today we're working on my x86 OS written in Rust. And today the goal is some form of TCP retransmission. So we have this OS. So if I write cargo run, what happens is it boots QEMU and it loads my kernel and it starts doing some like demo stuff. And this demo, I can like do a TCP connect and I can say like hello, and it'll get that data and it'll like send it back. We've got like a little echo server here. There's like UDP, there's ARP, right? In order to like resolve where to send this data to, it needs to like resolve a IP for a, it has to like resolve a MAC address for an IP. It's got to like work with the Ethernet driver, which is, or the Ethernet card, which is plugged in over PCI, memory mapped. Needs to do some like PCI talk with like the IO ports. We have like async await, so we can do this like event-based stuff. We're using like Rust's async API. So that's where we're getting in there. Starting to have like a semi-functional OS. And where we got to last stream was we kind of set up the infrastructure for retransmission. So we set up like a timer. We like passed in like the concept of time into our TCP subsystem, I guess we'll call it. We like intentionally dropped some packets after implementing an RNG, and then we observed in Wireshark that if we took too long after sending out our SYN-ACK during the handshake, we did get into this state where we did retransmit a packet. So that's pretty cool. And now where we want to go from there is we want to get like generalized retransmission. So once we've connected and we've like actually done our handshake, it gets like a little more complex, right? We have this like, oh, we're sending and receiving data, and how long should we wait before we resend? And like when we're sending data and they're telling us what they've got, and like, do we not send anything? You know, we have to like keep track of what we haven't sent and stuff, or what they haven't ACKed, etc., etc. So that's what we want to look at today. So the useful diagram to look at here is, don't have Firefox open, one sec. The useful diagram to look at is the TCP spec. And where is it? This guy. So this is basically what we want to implement. So we have this like stream of data. Let's pretend that like each one of these dashes is like data, right? And what happens is we're like everything in this window. This left is oldest, right is newest. This UNA stands for unacknowledged. This NXT stands for next packet. So like when we send, where will we send from? What index into our buffer is that? And then we have this plus the send window. So basically what we're seeing here is all of this data is data that we've sent, and the other side has said like, yep, got that, I'm good to go. Here is data that we've sent and that the other side has not acknowledged yet. And this is data that we haven't sent yet. So this this data doesn't exist as far as we're concerned. But we could send data if we wanted to, because like there's this room here. And this is like, if we got up to this point, we wouldn't be allowed to send data anymore, because the send window says like, hey, this is how much data I'm willing to receive. And if I like blast out a bunch and he hasn't answered any of it, then like, we don't know if we like, he's basically saying like, I won't have room to accept more. So there's no point in sending. You could send more, but there's no reason to. And in fact, there's reasons not to avoid like saturating the internet and stuff. Like a lot of the design in the TCP spec that I've seen so far is kind of indicating you could be less efficient and less intelligent, but the internet would suffer because of it, is essentially it. So let's just start seeing what we have to do to like get this in there. Then once we have what we think is like a semi-sane implementation, we're going to have to like find a way to test that. And it would be nice if that like way of testing was like baked into the OS forever. I don't want to have like debug code that we rip out later. I want to have like a debug interface. I think it would be fun to like, you maybe over TCP, you could like log into the kernel and say like, please enable this feature. That'd be kind of fun. And then we're certainly going to have problems. And so we can just start trying to sort through them and see how they work. So here, the first thing I'm going to do is put a retransmission queue up. Okay, let's just get going. So what we have here is in our kernel main loop, we call this demo function, which is where everything lives right now. Right now, our kernel is only a demo, and anything it does is just like by mistake for the purposes of being a demo. And we have these like different async blocks, right? We have like, here's like a UDP block, and here's a TCP block, and this is where like we do the actual TCP listening, kind of. This is where we hook up the APIs to be like, tell me when something comes in and I'll send it back. Here is like a service loop for TCP. So, you know, if we have things that are like timeout related, we might have to, like, without trying to send a packet, somebody has to be like, oh shit, we forgot to, they didn't answer. It's time to send something again. We gotta send it now. So that's kind of like what this guy's for, as well as like when we dispatch writes. So what we have is like one thread, we'll call it here. Thread is not the right word, but we can think of it as a thread. And in this thread, we like write some data. And that gets like put into this queue, but it isn't actually sent out until we call this like TCP service function. And that's because the TCP subsystem is like unaware of Ethernet. And so in order for like, we can like create the packet from the TCP subsystem, but then it's like, that has to go somewhere. And so how we've modeled it right now is that we monitor the TCP service. So we like run it every once in a while. And if it says it has data for us, then we chunk it out over our Ethernet driver. You could also do something else where you like had a channel where you like shove packets in from the TCP subsystem. And then that gets like queued up somewhere else that's like read from the Ethernet, but it doesn't like, you would still need someone who's like monitoring a source of data and sending it out. So we did it this way. Gotta love abstractions. Also, hey. Yeah, that's right. They're the only way to stay sane, unfortunately. It would be nice if we could like keep everything, you just pipe everything where it needs to go easily, but as software gets more complicated, you gotta pull stuff out. Yeah, so that's our loop. And so now the question is, if we wanted to do some form of retransmission, where does that live? And so it's not in here, right? Like we're from the user's perspective of this like API, he's just going to write some data and he doesn't care anymore. And so really it's more like in this like service side where we want to think about it. So this is modeled as like a future, where in Rust futures, what happens is they're actually they're polled, right? So that you have this one API poll on it, and what you do is every once in a while you call this poll function, but it's not polling in the same way that you like would normally think about it, where you like, you know, you poll, wait 30 milliseconds, poll again, or just hot loop polling something. It's kind of like informed polling. So what happens is like the executor of this, like when you write like async functions in Rust, you need like an executor who's going to call this poll. What happens is he will only wake up, in our case, when an interrupt fires. So we'll have like, everybody will see sitting there idle, the CPU sitting there halted, he's not doing anything. But then when an Ethernet frame comes in, then he's like, oh shit, got some work to do, and that's what like kicks off all the work. And in our poll function right now, what we do is we have this like async mutex so that we can like have like multiple references to mutable data. We like lock the mutex, and then all we do right now is we say, let's like check if anybody tried, like any users tried to write to the TCP socket, to any TCP socket, and if they do, we'll like transmit that up. Otherwise, let's see if we're like doing a TCP handshake and we didn't get an answer after a certain period of time, we're gonna just like resend the same data. And so what we have to do here is, in the same way that we're using this like timeout and resend for our handshake, we just have to implement something similar for retransmission for like the normal state. So what does that look like? Probably we'll have some sort of like retransmission queue. So I guess the first before we should probably check for retransmissions before we look for new data, right? If you have stuff that you haven't sent and you want to try to send again, it's like pushing new data onto the network in that case is just like no, don't do that, right? We're gonna need tracking variables for each of those states that we saw in like this window. So let's just kind of yoink this and we'll stick it in this connection, which is called connected state. So this is all of the things that we want to keep track of for an individual connection. Right now, all we're keeping track of is the sequence number and the ACK number, but in reality, there's going to be more things. So let's just kind of see what we're missing here. Okay, so we need the window, the next sequence number, and the unacknowledged number. So these are actually kind of already encoded in here somewhere. So send next, this is equivalent to sequence number, right? This is what, like, right now when we send a packet, we use the current sequence number that we're keeping track of. So that's the next pointer that they're talking about in that diagram. The unacknowledged is kind of tracked by this. So we have the ACK num. This is like the latest ACK number that we received from the other side. So send UNA is the same here, right? So this is the last thing that they act. So we're seek num minus ACK num is kind of like this area. Now we just need like the window size. So here we just need to figure out where we get that from. And I think it's provided by the other end when they open up a connection. So let's maybe pull open our OS. We can use this dump network flag that we have, dump network, and for now we'll just stub out this window size as 0. 1 second. Where does this come from? Connected state. Queue are constructed here. And if we just open up Wireshark after we run this, run, we'll send some shit over TCP. So let's just like, hello, and we get that back. Okay. So if I open up the Wireshark capture, is this right? We should see in here somewhere we should have sent hello. Since an accent here. Hello, here it is. Okay, ACK. So somewhere he like tells us what his window size is. And I think it's this, window 64240. Let's just make sure that doesn't change over time. Window 64240. Window, it's the same. Oh, here it actually here it shrunk. So that's interesting. I wonder if we have to handle those window size updates. Let's see, TCP window. Video? Window. The size of the receive window, which specifies the number of window size units at the center of the segment, is currently willing to receive. Okay, so I guess so maybe he sets the congestion bit as well and reduces the number. So here it's 240. Here it's less than 240. So let's see if his flags say that he wanted to reduce as well. So flags, ACK. Nope. So I guess what we have to do is on every receive, we just update the window size. That seems reasonable. We don't have to like keep track of, what am I trying to say? We just update it every time. So here, we can just take the window size from the incoming connection. And we have this as a U32 here, but this should actually be a U16 because it's only 2 bytes in the payload. Window size 2 bytes, 16 bits. Cargo check. Does that compile now? Yeah, we're chilling. Okay, and then we also have to say every time we get a frame, let's just update that window size. So we'll say state window size is equal to frame window size. Easy. Okay. So now we should have all of the pieces that we need in order to keep track of what needs to be retransmitted. So I think that there's here. They say that we should retransmit if we see a duplicate ACK, right? So maybe we keep track of duplicate ACK numbers. Then there's timeout base, which is smoothed RTT plus max G 4 times RTT variation. Cool. So this is essentially RTT can be measured from these. So what they mean by RTT is round trip time. So how long does it take for us to get an ACK for a sequence number that we sent out? And you can say like when we got like this versus when we sent this, I think. Yeah, the time between these is approximately your round trip time. Because if it was shorter, then these would be closer together. Right? This is like you're kind of assuming that they are going to send back an ACK, and that means that yeah, this is like essentially your latency, round trip time. Hey, can I tell you something dumb? Let's hear it. So I guess what I'm gonna want to do is I'm gonna start with duplicate acks, and then maybe figure out timeout retransmission. You're making a Python game engine. Fun. That's fun. Hey, can't call that dumb. I'm sitting here making an OS for no reason, so you do what you gotta do. Okay, so there's duplicate ACK, timeout based, congestion control. I think doesn't matter. So I think that let's just start with timeout based retransmission, or start with duplicate ACK, or it doesn't really matter, and we'll just see where we end up. So here I guess we can count the number of ACKs that we've got before. So like dup ACK counter is probably like how many? We're only ever going to count up to 3, right? I think I've seen somewhere that like 2 ACKs you can consider as like maybe like network reordering, but 3 is like probabilistically probably actually needs a retransmission. So we'll just use a U8 here to keep track of that. And then the other thing we have is like timeouts. So I guess each packet that we send out will probably need to keep track of when it was sent. And then we'll check later how long it's been from each one, and we'll use that. That seems reasonable. How do you test your OS? A VM? Yeah, so if I cargo run, what's happening is it's calling this QEMU wrapper script, which basically like sets up all of these like parameters for the virtual machine and then shows my kernel into it. QEMU says like, okay, here we go, I'm gonna boot this kernel now. And then we've got like some nice testability stuff where we have like the serial port of the machine is like piped into our standard output, which is pretty sick. It just means that like we get like you basically get like it feels like a normal application. Oops, there's missing stuff, so I can't show. There's also like kind of fun, this QEMU has this exit device, so you can actually like there's like a device plugged into your IO ports, and if you like write a number there, it'll like shut down the VM with that exit code, so you can get stuff like unit testing that correctly flags whether or not your test passed, etc., etc. What distro are you on? Nix OS on my host, but I don't know if I would recommend it. It's I don't know, it's kind of a meme. I like it, but whatever. I don't know, it doesn't matter. Okay, so sorry, I want to keep my head in the implementation space. So what was I doing? I was going to add a queue for how I'm going to add a queue for retransmission. Right. So let's go back into this connection. So it's going to be part of the connection. Sure. And in the connection, we're going to have like outgoing packets, maybe we'll call them, like, or unacknowledged. I think that's reasonable. Unacknowledged packets. And they're going to be like a vector of something. Probably like unact packet is going to be like a timestamp is like when we sent it. So this will just be a usize. Because I think that our timestamps can be like they're in the unit of the clock. And we're also going to have like the data. So we'll have like say like payload. And it's RCU8. So a reference counted pointer to a chunk of data. And here then we'll say we have like unact packets. Okay, and then when we initialize our connected state, we have our unacknowledged is going to be an empty vector. And what's the other thing? Dupe act counter, we're going to start with 0 duplicate acts. Nixos is one of those operating systems I 100% love and also 100% do not recommend. Yeah, I've got a lot of those. Like NixOS, Vim, like it's their... you know, I love them, but I wouldn't suggest. And it's like anybody who's asking, should I use this, is probably not the person who should be. And anybody who's like finding it by themselves and is excited about it is like, okay, yeah, I'll try to convince you not to. And if you still want to, then you should. I know I'm asking a lot, but what do you do in Godot? Not much, to be honest. The only thing I've done in Godot is this. Like, and that's not much. But it's free, and I like the concept, so it's kind of fun. I've opened Unreal and Unity a couple times, but yeah, I'm not ever doing anything serious enough that I'd be I feel like I would need to go farther than Godot, you know? Okay, so I've got my unacknowledged retransmission queue, my duplicate act counter, and so now what I have to do is just if the first thing is duplicate acts are easy to track, right? We can just say if dupe, how do I say this? If our act that we get in is already equal to the acknowledgement number that we have. Oh, sorry. This is I've just realized I've made a terrible mistake. Act num, this is our outgoing act num, not our incoming one. This is our incoming sequence number. And so we actually do need to keep track of their act num. So we'll call this like outgoing act num and incoming act num, maybe. And we actually do have to track those separately. Okay, so here, this is outgoing act num. So where is that? In our connection, we have outgoing act num is this. And our incoming act num is going to be frame.act num. There we go. So this is the last thing they act. This is the last thing we act. Great. And so now, if we get an incoming packet that doesn't have the act number that we expect, we just drop it. Great. Oh shit, sorry. Outgoing. Fuck. Maybe we need to rename these because this is already confusing. Sorry, so we'll call, what do we call this? We'll call this scene num? No, god damn it. We'll call it outgoing num, that's fine. So if our outgoing act num is not the sequence number, we drop it because we want to say that, like, we could buffer them a little bit. But we'll for now just not support out of order packets. That's fine by us. Here, this is again the outgoing act num is the sequence number plus the length that we got in, and our incoming act num is going to be frame the act num that they sent us, right? And what we should do is we can say that if the incoming act num is equal to state incoming ACK num, we increment the duplicate ACK counter. And this would actually be like a saturating add, because we don't want to accidentally go over the end. And I actually think that this doesn't modify, right? So we have to say let or state dup ACK counter is the saturated add. And that's fine. So here we have we send out the outgoing ACK num, not the incoming one. And sure, that's fine. And now all we have to do is we will detect the duplicate acks in the service loop. So here someone calls service, and here we poll, and we should now just say if connection dot duplicate ACK counter is greater than 2, we resend the latest thing in our transmission queue. The other thing we have to do here actually is we have to remove stuff from the transmission queue if let's write this down just so I don't forget about it. So if we ACK something, where is it? When they ACK something, we need to remove it from the transmission queue. We don't care about it anymore. We don't ever need to retransmit it. So here we'll take the ACK num that they sent us, and we'll say let's think. While the unacknowledged number, while the first thing in here has an ACK or a sequence number that's less than their ACK number, we can pop it out. So here, our unacknowledged stuff, it has these packets that have timestamps, and they also just need their sequence number. And the sequence number is actually U32. And I think timestamp was actually U64. Okay, so we can say, well, let sum x is equal to this if this is a unacked packet. If the unacked packet has a sequence number that's less than their ACK number, then we pop it. So we say state.unacknowledged, pop front. And now I'm realizing that this actually has to be a double-ended vector, not a single-ended one. So we'll just shove a vec-deque in there. Vec-deque. Alec, vec. I think it's under collections. So collections, vec-deque. And this is just essentially like a circular buffer that can grow from both sides. I think what they do is they like allocate two vectors next to each other and grow them in opposite directions or something, and then treat them as a circular buffer, if I remember correctly. So here we say like while it's this, we pop front. Otherwise, we break, right? Because we can probably assume that the packets that are in our queue are in order, and if they're not, then that's a bug. So probably somewhere we should assert that, but whatever. Blaze it, doesn't matter. YOLO, if you will. Okay, so here we've got our incoming packets. We pop stuff from the queue, and now all we have to do is look at retransmitting. So if their duplicate counter is greater than 2, I guess we just retransmit everything up until after that ACK number. That seems reasonable. We actually should just do we just retransmit everything in the queue? We could. Is that what they want us to do? Who fucking knows? And I guess we should also we could consider. I was gonna say we should keep track of things that we haven't sent as well, because of the window size. So maybe we assume that everything in the unacknowledged queue has already been sent, and we'll add another queue. In fact, we already have another queue for things that we're going to send. And so we'll just have to make sure that when we try to send something, we only try to send it if it's like the window size will allow it. That seems reasonable. So let's actually just stub that out now so I don't forget. So in our service loop, again, that's actually just right here. We'll say fix me check window size before sending. So I guess what we should do is we should check the last thing in our duplicate in our sent queue. So if let some unacked packet is equal to the connection dot unacknowledged dot back. So this is the last thing in there. If we have anything in the queue, we'll look at the back unacked packet sequence number, and we'll also have to keep track of his like final sequence number, which we actually don't have access to here. So we'll just say this is unimplemented for now. We'll come back to this. Back to the dupe ack counter. So we get 2 acks in a row. We'll just send everything in the queue. So for we would for loop this, except we can only return 1 packet at a time. So what we'll actually do is we'll just return the 1 packet, and then on the next iteration of the loop, we'll return the next one over and over and over again. So what we can just do is we can say connection unacknowledged pop front. And then we say return poll ready packet dot what's in here? I forget. This is a unacked packet. So here we have to say if let some packet is equal to pop front. So like this queue might be empty, and if we get duplicate acks and the queue's empty, that's actually totally fine and normal behavior. And if we do get something, we should say return poll ready packet dot payload. Yeah, there we go. And I was gonna say we just send everything, but that's actually a problem because we can't pop this item off. If we pop the item off, we won't, like, next, if they don't ack it again, we lose track of it. So how do we make sure that we only send it out now? Think about it. Let's think about it. So if we could like keep a pointer to where we've already sent out again, where we've like retransmitted. We could spam this forever, or we could reset the duplicate ack counter. That seems reasonable. So we'll reset the duplicate ack counter, and maybe what we should do here instead is we'll pretend that every element that like after this one is a new thing again. That seems reasonable. So we'll make a new toSend queue. And this will just be RCU8 probably. This is going to be like data. And what we'll do is will just behave the same as what we like when we get data here. Maybe not. That'll make like acking kind of tricky. Because like our ack numbers would have to be reset and stuff, like the numbers that we're sending out. Oh no, our sequence numbers, sorry. Oh, that's okay. That'll work. So what we can do here is we can say that our connection.sequence number is going to be reset. So we'll make that our connection sequence number. This is going to be reset to like whatever it should be at the end of this, which is packet.seq_num plus the payload size. And I'm realizing now that we actually have like metadata about the payload that we want to keep. Right, we have, let's see, generate TCP push. So we put all of this junk in here. And some of the stuff we put in here is like the data, but we actually have to keep track of this separately because we need the like length of it. And in reality, I think that I read somewhere that if we like retransmit, I think our ACK_num should still reflect what we've seen, right? If we send something and we've only ACKed like the first 5 bytes, and then we like get 10 more bytes and we try to retransmit, we should ACK with the new 10 bytes. Or else on their side, they're going to think that we haven't received the last thing they sent, and we get back into like back and forth in this loop where we're just sending each other the same packets over and over again. So maybe what we should actually store is not the generated buffer, but maybe we should store the parameters that we're using to generate the buffer. That seems kind of reasonable. So I wonder what that looks like. Let's kind of like just comment shit out until we can compile again. So I think it's compile and run. So let's just comment this stuff out. And I think everything else is probably fine. We're close. What do we got here? So here, we don't have an ACK_num, we have an outgoing ACK_num. Here we have vec, but it should be vec_deque. So that's here. This was converted into a vec_deque. And what else have we fucked up? Connected state is missing toSend, so we'll just delete that for now because we're not using it yet. Okay, so we compile again, and now let's try to like adjust this TCP frame params stuff to take in a reference counted pointer here. Since we want to be like stashing this, now all of a sudden like using it as a reference is not what we want to do. So let's take a look at that. So here, this guy is generated with this data. So this data here also has to be an RCU8, which it is, which is sick. Okay, and then wherever this guy's called from, he can take this by value, not by reference. And here, this can just be passed in by value, actually. Everyone's happy. Okay, cool. So now we have owned pointers instead. We have a problem here at 417 in TCP/RS. What's happening there? Here we try to put in a payload reference, but this should be an RC new. Like this. Yeah, okay, that works. And we have one at 547 as well. So we'll just give it the same treatment. Okay. And now we're close. We have TCP/RS 224. What happens here? He doesn't like this payload because this payload's an RCU8, and so now we just have to pass in a ampersand here when we generate our packet. Cool. And now we have to clone something somewhere. So this is at 268. Here, we can just stash the length here. We can say let payload length is equal to data.len, and here we just plus equals payload length. As we did. Alright, check. Cool, everyone's compiling again, and now we can stash these TCP params, which is cool. So here, we call this generate TCP push to be able to like wrap the TCP packet generation in something a little cleaner. But now instead of generating the push and getting back a vector of data, we should actually try to get back the TCP frame params, right? Because these are the things that we want to stash so that we can use them in the future, which means that here we have TCP frame params like this, which means, do we still want to increment the state here? Yeah, that's fine. Sure. And so it means that when we call this, we are assuming that the payload or that the state will be like, this is immediately going to be sent out, but I don't actually like that now that I'm seeing it. So we will adjust this. Yeah, no, that's yeah, that's fine. That's fine. I can go here. Okay. And then here we need to call this like generate TCP push. And this is the, oh no, sorry, generate TCP frame from the params. And probably this needs like an into on it to make it an RC. Yep. Okay. So let's stash the params. So here we'll say that connected state dot unacknowledged push back, and we're going to push back an unacknowledged packet. And here we are going to keep track of the timestamp for sure. So this is going to be like, we're going to need like a reference to time in here. This will be time dot now current. What's like the API here? Get time dot get. This timestamp needs to be a U size is what we're using to track. Our unacked packet, now instead of keeping track of seq num and stuff, he's in payload, he's going to keep track of the params that we use to generate. Okay. And this is params here. Okay. And then we generate the packet and send it out. I don't really, I'm looking at this like connected state usage. I'm really not liking this. So I'm just gonna say fix me, hidden mutation of connected state. This guy needs a reference to time. So here I think we have one already and we can just pass it in. So I think it's the third parameter. Yeah, third parameter. Which is just self.time. This. And I think we compile now, cargo check. No, we do not. 520. This needs to look at the params that we sent instead of just using the seq node directly. And then we have 645. He doesn't like that we need to clone this guy, I guess. Or we generate the payload first before we move him into our unacknowledged buffer. So this goes here into payload. Okay, so now we have a frame that we generate. We get the parameters for that frame. We store the parameters for that frame. We generate a buffer out of those parameters, and we send those out. Now, we have to handle retransmission. So we'll come back here. And we'll say that on retransmission, what do? We have these params. And now we can say that the sequence number, we're resetting our internal sequence number counter to be the packet that the packet after when we reset. That seems reasonable. So then on all future writes, we will be using that old sequence number. And then we can go back into this like other thing we were doing, and we can say that like we'll take every other buffer in this like retransmission queue and just pretend that we never transmitted them in the first place. Which means that we'll say while let some packet is equal connection dot unacknowledged dot pop front. We will say connection to send dot push back the packet dot params. Packet dot payload even maybe params payload. Yeah, so now we will regenerate those params next time, and that's okay. Yeah, sure. Okay, so there's some shit we're missing here, so this is going to be as U32. To send doesn't exist yet, so let's look at that. And here we have to say generate TCP frame from the payload. And this is actually param, sorry. And we need to convert this into a reference counted slice. And what doesn't it like here? What doesn't it like? The trait from vac-u8 is not implemented for outgoing TCP packet. Oh, so this needs to actually be converted into one of these guys. So we'll say that the payload is this. Oops, I got lost here. The payload is this guy. Where am I? Here. So the payload is this guy. And this all looks good. And so now we can say let return is this thing, and then we return the return. We forgot a colon somewhere, or we accidentally deleted it, I don't know. And now all we're back to is we need to like make this like to send queue. So what happens is when we pop all these things off the unacknowledged queue, we need to put them somewhere. So we'll just put those in a to send. And this is going to be a RC U8 queue. So a reference counted slices to things, to like data that we kept track of. Now, instead of polling directly for new things that the client wants to, like, that our user wants to send, we first need to check if there's anything that we need to retransmit. So we'll say if let some data is equal to self dot connect or connection to send dot pop front, so the most recent thing. We use that data. And we can actually do like something a little tricky here. We can say, instead of using this match that we were doing before to say like we're pulling this connection directly, we'll say that first we'll check the to send queue, then we'll check the result of a poll on our incoming data. So we'll say else if let poll ready equals this. And then otherwise, we continue. And then these data types are like the same, so we can convert them. We can call this like generic write request. And I wonder if that's it. I wonder if that's it. Cargo check. We're missing the construction of that. Is it 48? The construction of this like outgoing, or this like to send queue. So let's say to send is vec deque new. Check again. And we're compiling. So I guess now we need to simulate duplicate acks. And I think we can do that in a unit test. So let's think about how we would do that. We'll call this test dupe ack retransmission. We still have this source IP and dest IP. We have this like construction of the TCP subsystem, which we should probably pull out into its own function. So we'll say let function generate TCP returns a TCP. And we'll just copy paste this shit that we did here, where we like construct our wake up list, a RNG, etc. Wait, do we not need an RNG in here? Oh, we use that in the handle frame. Gotcha. So we'll do this. Generate TCP. We return this. Here we say let TCP is equal to generate TCP instead of this, which means I think we can get rid of this, and this. Then we can copy paste this down here into our new function. And this actually is a problem. We actually need access to these things. So we'll say that we'll create a mock, right? Or maybe calling it a mock isn't really reasonable. We'll say that we'll call it a fixture. So this we'll have a struct that's like a TCP fixture. And in this fixture, we have the TCP, you know, our subsystem. We also have the time in the wake up list. So this is an RC monotonic time. And maybe, I don't think we need this wake up list directly yet. We'll pretend that we don't. And here, this returns a TCP fixture instead of a TCP. And then we say TCP fixture time TCP. Easy. Okay. Maybe we'll just call this fixture the function. And we'll say fixture like this. Let fixture is equal to, we'll call this gen fixture. Sure. Sure. So this is gen fixture here. And probably a bunch of stuff won't compile anymore because of this. So, yep. It's all sorts of fucked up. So 679. So first of all, this needs to be a proper type. Then everybody who's using these guys directly now needs to access them through the fixture. So here we have TCP. This needs to be fixture.tcp, and we'll just search and pop these guys on there. We run cargo test, and now we do the same thing with time. So time is fixture.time and fixture.time. And our tests are compiling. They pass again, probably. Cool. And now let's write a test for like duplicate acks. So what happens? We first need to generate a normal handshake. So we need to generate a SYN ack, and then a what's the other, like an ack. And then we need to send data and ack send data 2 and ack data 1 3 times. Right, that's what we're trying to simulate here. And then at the end of this, we should see a retransmission. That's what we want to see here. And that's going to be a pain in the ass to generate, dude. Holy shit. Okay. So I guess we'll just start. So we'll say gen TCP frame that has TCP frame params. And we just have to start throwing these in here. So the first thing that we need is the source address. So this is going to come from the source IP. So we'll call this remote and local. We have a source address. This comes from the remote IP. Guest address comes from the local IP. That's us. The source port is 134. And the guest port is 5678. Source port, guest port. The sequence number they get to define it, so it's just like one, I guess, 150. And then the acnum, I think, comes in with 0, I think, on a SYN. Let's see what the acnum on like a unacted thing is. So here, let's look. Oh, wrong section, that's why. Act number 0, solid. And the flags are going to be generate TCP flags, which takes in TCP flags params, I think. This is the same thing. All we need from here is SYN. So here we delete these. All these go to false. And SYN is true. Window size doesn't matter. Urgent pointer is 0, and the payload is empty. Okay. So we'll say let SYN is equal to this. Now, realistically, this is like a giant thing. Do we want to like abstract this into a function? Maybe, maybe not. Let's go with not for now, and we'll figure that out later. If it starts to look bad, it'll start to look bad. Okay, so the SYN ack. We swap source and dest here. So source and dest are swapped, right? Because this is a response. And I guess I was gonna say, do we actually need to generate the SYN ack? Probably not, because our TCP subsystem just kind of assumes that we sent it out. Oh, he'll make it. Okay, so we don't actually have to generate this. So we can say let SYN ack is equal to fixture.tcp.handle frame, and we pass in the SYN. We also need to pass in all this other shit. Like this. So we have the frame, which actually needs to be parsed now. So we'll say this is a TCP frame new, parsed from the buffer we just generated. The source IP is the remote IP. The dest IP is the local IP. And the RNG is fixture.rng probably. Oopsies. Okay. Now, we need to move ourselves into the connected state. So I think this needs to be in await. Like, now we pretend we send the SYN ack out, we get an ack back. So this ack is going to look similar to this. Except we are not going to have SYN here. Our ack is going to be true. And here we're going to use the sequence number that we generated in here. So we'll parse this frame so we can get it out. And here, so what did they act with a sequence number that is their sequence number again. So 150 is fine. Their acnum is going to be SYN ack dot seek number, I think. I don't actually remember. We'll see. And the window size, sure, this can stay. So now we should ack. We'll shove this into our TCP subsystem, and this should convert us into a connection that exists. So I guess we need to create a listener. So TCP listen on the local IP local port, or guest port, I guess we'll call it for now. And so after this, like, just to make sure that our test is working, we should at this point be able to get a connection. So this should be listener connection. Hello, why isn't this working? Listener is a, oh, it's a future, so we await this. And here, we actually have to do something a little tricky. So if this fails, we don't want it to hang forever, which means that here we need to do a future poll immediate listener.connection. And so what this will do is it will try to get the value out of this once, and we want to make damn sure that this is correct. So we'll just say match here, and if this is poll ready value, we're ready to go and we can use this. And if it's poll pending, we say that our test failed. So we'll say return error connection not ready. Okay. And so if I run cargo test, I hope, well, there's a lot wrong here, invalid syntax. But if I run cargo test, I hope that doesn't crash, but it doesn't even compile, so how could it crash? It doesn't fucking compile. So one of these things we have to do is, this guy should not return a U8, this should return TCP flags, which is a TCP flags of the red. Everywhere we use this, we convert him, so I'm just gonna delete that really quick. Delete that really quick. Delete this really quick. And here we call this flags, and I think that's all of them. Cargo test. Cargo test, please. Thank you. Okay, so we forgot to await this thing. So when we call this poll immediate, we still have to call await. The await is just so that it, like, Rust will pass in the things that it needs to poll, but it's not actually going to block. It promises. Here we're having some problems. So 861, we forgot a semicolon. 825, we forgot the RNG on the fixture, so it's just here. When we generate our test fixture, we just stick an RNG here. So we'll say let RNG equals RNG new initialized with a seed of 0. And we pass in the RNG. We say that we have an RNG in here. And now everywhere we use the RNG. Oh, it needs to be a mutex to RNG actually. So we do this mutex new, construct it, and here we just need to pass in fixture.rng. Cargo test, are we good? We're getting closer. So we fucked up at 856. This needs to be an ampersand fixture.rng. This doesn't return poll ready. This will return option, actually. That surprised me. So this would be some, and this should be none. And we're so close. We're so close. So here, it's that the syn ack at 829 is not the right thing. Oh, right. So we should expect that we return something here. So when we call handle frame, we might not have anything to send back, right? When we like get something, we might go like, yeah, meet up, okay. But in reality, most of the time, we should say, oh, we need to act that. And then so we need to write that down. So we'll say in this specific case, we know that it's a bug if we are not acking it. So we'll say if it's some v, we return v, and if it's none, we say return an error, no sin ack for sin. I guess we can put a semicolon there. Start our test. Do we compile yet? Oh my god, 833. We forgot a semicolon. Of course we did. Yeah, that makes sense. And then 755, we forgot to put fixture here. Like this. Okay. Thank God. Test dupe act retransmission. We are hanging. No, where are we hanging? Is it before the, is it at this await here? That's fine. That's fine. This handle wait is failing. That's interesting. I wonder why. So this guy, is he like trying to lock a mutex or something that he can't have? What could he possibly be hanging on? The lock on listeners? I wonder how we test this. I guess we see who's returning pending here. Or returning none. Handle frame. Oh, there's no none. It's just someone here is awaiting on something that isn't working. Let's see. I wonder if we can like turn on the logger. Is the logger should be on if I remember correctly. Let's see if I just write like info hi. Do I see that? No, I don't. Warn hi? Shit, the fact that our logger isn't initialized in the test is actually so annoying. Is there a way to turn it on? So in main, call test main somewhere, and this should be, the logger should be initialized here. Can I info something here? Hi, Mick. Interesting. I don't understand why that's not running, because here we only go into the test main once we're running this async section. Testing. Oh, it's because we like restart the executor. Oh, that's such a pain in the ass. Okay. Okay. So probably here, if I did like logger service or something in here, I bet that would work. But I'm gonna just revert to print lines for now and deal with this another day. Okay. TCP subsystem. Here. So this is hanging when we try to handle a frame. So let's just look for awaits in here. So this is locked TCP. Locked. This is RNG done. We'll test this, see what we get printed out. So we say locked RNG done, locked TCP, locked TCP. Aha! Oh, I see. We actually have like a guaranteed deadlock in here. It's because when we recurse into this function, we like still have this mutex locked, and then we try to lock it again. And this is like also because of a bug. Hey, there's our logs. Nice. Okay. So the problem is that when we run this handle frame, we are passing in the sin again instead of the ack. And so that's like resetting the connection, which is expected. Okay. So if we don't, now when we run this, we should see our connection initialized. It is not initialized, so we are now in the world of trying to figure out a bug, which is very fun. Very, very fun. Okay, let's take out all these print lines that were in the way, and I think there's like highs written in here, so cargo test. Does that clean up our output? Nice, it does. Okay. So now back to this test. So we're trying to simulate the handshake. So we've sent out a SYN, we get back a SYN-ACK, we pretend that we act the SYN-ACK, and our connection, we expect that to be ready at that point. So the question is, why the fuck not, right? And so I guess we can start trying to print why not. So let's first see if we get here. Hello. Hello. Which is printed, right? So the fact that we print here is a good indication of this, right? And actually I'm looking at which, yeah, so dupe ACK transmission. Oh, it's not getting called in that one. That's what, okay. So now the question is why. So let's print up. I wonder how we can debug this. So we can print here and we can say like SYN accent state. We can see if we got in there at all. We sure did. And we'll say here, we could see if we're turning early because of seek num wrong. Which we sure are. So here we just have to make sure that in our test, we're sending the expected sequence number. Which we expect to be the ACK num that we previously had. Interesting. So what is this supposed to be? We got sequence num, and we're looking for this num. And this is frame seek num and ACK num. So oh, it's because we forgot to add one. Oops. There we go. Okay. Cool. So now we've gotten to the point where we've simulated a TCP connection in our test to the point where we have a connection, and now we can start trying to send data. So we can say connection send hello world. Await probably. This is probably async. We'll send a second thing, which is hello world 2. Or sure, yeah, that's fine. Now, what we want to see is if we send back an ACK for the first set of data over and over and over again, we should see that we expect a retransmission. So this doesn't actually trigger a send, right? So now we have to say that our if we call service on our TCP service, we should get back this packet. That's what we expect in this test. So how do we test that? We say let frame is equal to a TCP frame new. So we like get like a chunk of data out of our TCP service, and then we parse that as if it's an incoming frame. And now we just want to make sure that the frame payload is equal to hello world. Otherwise, we are not doing what we expect. So cargo test. We fucked a lot up, so this needs to wait on it. Because we're in async codes. You just gotta trickle awaits all over the place, you know? This is an outgoing packet, so we actually need this to be payload, I think. Connection is not, this is send is the wrong word here, so I think it's right, maybe? That's better, and here we need to say RC new for both of these. Otherwise, it doesn't know how to convert those to shared references. That's actually still wrong. Do I need to like dereference these? What the fuck? The trait from is implemented. Ooh, so I can actually write these as strs instead of byte strings, and then probably that just comes for free. Dot into here, I think, maybe. That's better. Cannot infer type for parameter t on the method right. Oh, I see. What am I missing? What am I missing? So this right thing takes in a data of t. Oh, do I have to put this in like a vector or something? What do I do in main? I just get the data. Great. Great, great, great. I know that at some point I've written a byte string. Into RC U8. So the trait from RC string is implemented for this. So maybe I need this to be an RC string. God damn you types. I love you, but I hate you. Yeah, this is interesting. So it actually needs do I do like an into RC stir or something? Or do like RC stir from? Dude, why is this so hard? Oh, there we go. Okay, so that's it. So we'll do this and do hello world 2. And here they don't like something. So here we say let frame is equal to this service.await, right? Then we parse the frame payload. We have to do this like double let binding so that the like lifetimes match up, I guess, right? Because it doesn't want those to be temporary because they get freed too quickly. And let's test that if we say that this is hello world 2, this should fail. Good. And if it's hello world 1, it should pass. So then we can do this again. The second thing that we pull out of our TCP service should be the second thing we tried to write. And now what we want to do is we want to get the thing that we're trying to ack. So we'll pretend that we receive the first frame from the other side and we drop the second frame, which means that we should see we've already parsed it. So we can say frame sequence number plus frame.payload length is this is going to be our ACK number. So we'll create a new ACK here. So we'll call this like data1 ACK. And this is just going to be the frame.sequence number plus frame.payload.length. And this isn't the sequence number, this would be the ACK number. Okay. So now if we send back, we can send this ACK into the fixture, which is something like, where's our like handle frame here? So first we should make sure that we want to make sure this is none. So we'll say let response is equal to this, and test that true, that the response is none. And this should be data1 ACK. So here we forgot to put some brackets here on the payload. And Oops, we've got like a weird extra sequence number there. And we can do this as U32 to do some cycle check conversions. And we are failing, so 906. So this is failing for some reason, so let's print the response and see what we're trying to send back. So we can say TCP frame new response. Unwrap. Come on, what are we missing? As ref, sure. Okay, so we... Oh my god, why are these all in one line? That's so annoying. Okay, but whatever. We are trying to send back... Are we trying to ack their ack? We definitely are. That's a bug. We shouldn't be doing that. Okay. Dude, that's so fucking stupid. Okay, so when we're connected, we should only be trying to return something if there's a push. That is what happened. So why are we trying to ack their ack? Why are we trying to ack their ack? Because this is not said. Let's just double check our state. So that's here we can say we can just log our state in each of these. And that'll give us a clue. Line connected. We sure are in the connected state. So why the fuck are we acking their ack? Oh. We should only act... Here we go. If they are pushing data to us, then we act. Otherwise, we do nothing. Okay, cargo test. There we go. Okay, so this shouldn't unwrap, and we can test true here. Mwah. Okay, there we go. So here we send an ACK for some data. We get a data piece of ACK for some data, and we don't. We shouldn't resend either. So here we should also. The next thing that we get from the service loop should be the second frame. We'll cargo test. Okay. And then we will just inject data 1 ACK again and again. And sure. So here we ACK data 1 2 more times. After the first one, we run service, and we should get nothing. We should get nothing. Which means that here we should run this, like, poll immediate thing to, like, extract the value without awaiting. In fact, this one we should probably do that too. Fuck. One sec. Let frame is equal to futures, future poll immediate, fixture TCP service. And here we need to convert that into a frame. So say match this guy, and if it's some value, we propagate. And if it's none, then that's a mistake. So we say return error. TCP service did not return a value. Sure. Cool. Cool. Yep. Yep. So do we do anything with that? I feel like I've got lost because there's just so much fucking code here. If only I had thought of splitting these into smaller functions that I could read. Fuck. Okay, so we send the ACK here. Aha. This is where I want to throw this. So here we should see hello world. Here we've ACKed once. Here we, oh god. Here we pull another frame out. Here I should say for hello world 2. And then we maybe we send back the same ACK. Let's think about this. I think our sequence is wrong. I initially had the sequence send data, send data 2, ACK data 1, ACK data over and over again. But actually, like in reality, we wouldn't ACK data 1 if we received data 2. So we can actually say that we can send data and we can push /ACK data 1 on all of these from the other end, and that's when we should trigger a retransmission. So let's do that. Right, so we actually don't need this hello world 2, which is here. I guess we can send 2 things to make sure that when we retransmit, we send both of them again. God damn. This is tricky. Okay. So here, instead of data 1 ACK, well, first we'll data 1 ACK. Then we will make sure that we've pushed out the second frame, which we do here. And now we can just ACK data 2 more times. So let's say ACK first segment 2 more times. Here there should be no more data. So here, after we've sent first 2 packets, nothing to do. And so this should be just, we can just test this as none. Or test true. Oh my god. Is none. Okay. Just to check my sanity, because this is getting, like, freakishly hard, let's just make sure this still passes. Fuck off. Here we need to await this, probably. Here we need to await this, probably. Alright, test. We're close. Here, this is at 881. This needs to be awaited. (884), we need a semicolon. Probably here we also need a semicolon. Come on, baby. 931. Probably we need a... What the fuck was I trying to do there? No payload on type TCP frame. Oh, so probably this just is a function call. Okay, cool. So we're passing. That's a really good sign. So we are good up to here. Now, we want to ACK the first segment 2 more times while pushing data. So here, we'll just say data. Let's call this like data 1 ACK 2 and data 1 ACK 3. I guess with the way it's implemented, we don't actually have to push data. So we'll just say, if we act this 2 more times, we'll just send data 1 ACK again twice. So we'll say fixture TCP handle frame TCP frame new data 1 ACK. So we can just actually call this twice. Womp womp. Now when we call the service, after the first time it should be none, and at the second time this should be something. It should be the retransmission. So this should have is, well, let's say is none for now, and we should expect this test to fail in this case. So here we should say 2 acks, no retransmission. 3 acks, transmission, please. Okay, so this succeeded, which is a problem. That is a problem. So now we're in a state where we need to actually test, start logging something and seeing where we're breaking. So let's start by just saying the duplicate ACK counter. So let's look at this duplicate ACK counter. He's at 2. Oops, we should actually reset him as well. If it's not the same, then the duplicate ACK counter goes back to 0. And now let's go down to our polar and say print line connection dupe ACK counter is connection.dupe ACK counter. So we actually do get him 0, 1, 2, which is what we expect. What am I missing? Oh. If it's 2, that's a problem, I guess. Okay, there we go. Yeah, okay, there we go. So now we do, in fact, get our retransmission after 2x, which means that this test is working. This test is a fucking disaster, so. And we'll say fix test and make it readable. But in reality, we should be able to test now, like for real, with the host, that we should be able to test that retransmission is working. So what we should be able to do is we should be able to do this same sequence outside of our unit tests, and that should trigger the same behavior. Which means that in our, so let's check with this. So we'll say this is a duplicate ACK retransmission. And what we should do is we can simulate this by basically just dropping our first attempt at sending a packet. That seems reasonable. Yeah, so if we go to our service loop, we can say attempts is a reference to a usize. Or it's a reference to an atomic usize, maybe. Attempts is a reference to our self.attempts. And we have this like list of attempts in our TCP service. At first, it's going to be 0. And here, we'll say that our first transmission, we'll say if attempts, self.attempts.fetch add 1, ordering 6, just the like complicated one. Oopsies. What the fuck? Core. Oh my gosh, my language server crashed. So we'll just restart really quick. Ordering seek syst. So we say if this is equal to 0, we return poll pending. Because like the idea is that like we add 1 here, but the first time we just say like fuck it, we actually won't return the thing we need to return, and so that simulates a dropped packet on the outgoing side. And this is actually in the core sync atomic ordering sequencist. And what I think should happen is if we run this now, cargo run with dump network, we should try to connect. The handshake should succeed. And we write test once. That test fails. And what I was expecting to see was a test retransmission. We should eventually see that test thing come into us. But we never saw that. And so a question would be, why? So let's look at Wireshark. And so let's think. He should send us this. He sent us test, then he sent us D, right? And when he sends us D, he should be sending us an ACK for nothing, essentially. So let's see if we can find that. Test D. And here his ACK number hasn't changed between those, right? So that's a good sign. But then the question is like, why didn't we retransmit? And it's because we're never pushing stuff into the retransmission queue. Because we didn't call this write request outgoing packet. Oops. So we actually should have done this. We still need to call this write request. We just have to return poll pending instead. There we go. So this should update our internal state. And that should cause the problem. Hey, look at that. That's sick. So here, what we should see is okay, let's get a more simple test here. So we netcat. Hello. We get nothing back from our echo. So we say hello again. And then that triggers a duplicate ACK, which results in Wireshark giving us, we should see if we open up the Wireshark dump, we should see a retransmission, which we do. So, oh no, wait. This shouldn't be considered a retransmission from Wireshark's perspective because it was never sent out. So let's, well, maybe it is. Let's see. So we say syn ACK, great. We push. So let's follow this particular stream here. So syn ACK, handshake complete. Then we push out hello, smiley face. And we receive that. Great. Then we don't send back what we sent. right? Then he sends us, sorry. Then he sends us hello question mark because he never saw a response. And we go, oh yeah, here we go. We say previous segment not captured. But here is this our retransmission? No, this is the retransmission. Ah, okay, so previous segment not captured. Sick. Okay, this is exactly what we want to see. So we ack their second request, but it's like out of order. And then we go like, hey, what the fuck? And we send again. And then we get everything acked on the client side. That's sick. Very, very sick. Okay, so we didn't get as far as I wanted to. I was hoping to get timeout-based retransmission working today as well. But I think what actually ended up taking most of the time was trying to like trudge through this unit test that required just a lot of code. So I think probably what I'll do is off screen, I'll try to like consolidate this a little bit and make it easier to work with in the testing side. And then that should make the implementation of timeout-based retransmission easier tomorrow. But either way, that's pretty sick. So what did we do today? We implemented TCP retransmission on duplicate ACK. And it seems like from our tests with Netcat and our unit tests, we have some form of indication that it's doing what we wanted. And that's cool. So I think I'll call it there. Thanks for watching. If you like what you saw, you can always catch up on YouTube if you miss, or you can tune back in most days at 2 p.m. Pacific time. If you're watching on YouTube and you want to catch live, ask questions, etc., feel free to pop into the Twitch. Twitch is in the description. Source code for the project is periodically pushed up to my GitHub, which is just the same as my Twitch and YouTube username. Yeah, thanks for watching. Catch you on the next one. Bye!